Welcome to The Explainer. Today, we're diving straight into a massive but kinda invisible risk flowing right through the pipes of the buildings we live, work, and shop in. I'm talking about the built environment, and specifically, the hidden sustainability and financial risks tied to water management. You know, we usually think of real estate in terms of square footage, location, maybe aesthetics, right? But what's going on behind the walls and literally underneath the foundation can absolutely make or break an asset's long-term value.
Okay, let's dive into this. Because water, it's rapidly becoming the silent budget killer in the built environment. Think about it. What actually happens to real estate when the tap runs dry or when water just becomes prohibitively expensive? Every single day, buildings consume staggering amounts of water. Whether it's the plumbing fixtures, building equipment, massive cooling towers, appliances, or just landscaping irrigation, the operational dependency on water is absolute. We literally can't take cheap, infinite water for granted anymore. To ground this in reality, take a look at this direct quote from the SASB Real Estate Industry Standard. We are facing, quote, expectations of continued increases because of overconsumption and constrained supplies. This isn't just some abstract environmental talking point. No, it is a hard, inescapable financial reality. Historic water expense increases are a documented trend, and the forces driving these costs up, they're only accelerating. It's a direct threat to the bottom line of property owners and investors worldwide.
Section 1. The thirsty built environment and the massive water consumption of our buildings.
When we think of massive water consumption, our minds usually go straight to vast agricultural fields or heavy manufacturing, right? But our buildings are incredibly thirsty. The sheer volume of water required just to maintain a comfortable, functional indoor environment is immense. For property owners, whether they pay the utility bill directly or pass it on to tenants, this consumption represents a massive ongoing operating cost. And that brings us to the financial stakes. Water efficiency equals asset value appreciation. Effectively managing a building's water efficiency doesn't just lower direct operating costs, though that's huge, it actually increases tenant demand. Today's commercial tenants really want to control their own operating costs, mitigate their environmental impact, and maintain a solid reputation for resource conservation. So if a building is highly water efficient, it commands higher rental rates, maintains higher occupancy, and ultimately drives the overall asset value, right?
Section 2. The Water Scarcity Storm and Macro Pressures Squeezing Our Supply.
To really understand why water efficiency is so absolutely critical right now, we got to zoom out. We are facing intense macro pressures that are severely constraining our global water availability. It's not just about a dry summer here or there, we're looking at a structural shift in how much water is available to support our expanding built environment. The source material identifies 4 specific threats compounding this crisis. First up, global population growth. That means a rapidly multiplying demand for a fixed resource. Second, we have population shifts. Millions of people are migrating to dense urban centers and, very often, to regions that are already severely water-stressed. Add to that pollution, which is steadily degrading the fresh, usable water we do have. And finally, climate change. It's unleashing frequent, high-impact, extreme weather events, prolonged droughts, and intense seasonal variability. Together, these 4 forces are creating incredible volatility in water costs and availability.
Because of these extreme macro pressures, guessing just isn't good enough anymore. Frameworks like the SASB standards, which are now under the International Sustainability Standards Board, actually require entities to rigorously track and disclose these exact water management risks. Investors need to know if a real estate portfolio is truly resilient against these supply constraints. They demand standardized, comparable data to evaluate who is really prepared for this water-scarce feature and who is painfully exposed.
Section 3. Measuring the risk and identifying the danger zones.
So how does the real estate industry actually quantify and measure this looming invisible threat across massive property portfolios? Well, you know the old saying, you can't manage what you don't measure. In real estate, measuring water risk requires pinpointing exactly where your most vulnerable properties are located. Now, what's really interesting about this metric is how it grounds abstract climate risk into hard, actionable data. The SASB standard relies on the World Resources Institute's aqueduct tool. It classifies regions as having high baseline water stress if that stress level sits between 40 and 80%, or extremely high if it breaches that 80% mark. This takes the guesswork out entirely. Property owners must disclose the percentage of their floor area located specifically in these highly vulnerable danger zones.
And it's not just about location, right? It's about volume. Real estate portfolios are required to disclose their total water withdrawn in these high-stress regions, measured in thousands of cubic meters. By forcing disclosure at this massive scale, investors can immediately see just how heavily a company is leaning on the most fragile water systems on the planet.
To understand if a portfolio is actually improving, they use a metric called like-for-like percentage change. Basically, this compares a property's water consumption year over year, but it crucially excludes new property acquisitions, sales, or buildings undergoing major renovations. This gives investors a clear, apples-to-apples view of whether the core portfolio is actually getting more efficient over time without the data being skewed by major real estate transactions.
Section 4. The base versus tenant divide. Who controls the tap?
Collecting all this data is where things get really complicated. If we zoom into a single building's water meter, we uncover one of the most fascinating operational hurdles in commercial real estate. The person consuming the water is very often not the person paying the ultimate utility bill. Think about a large office tower. You have the base building. That's the water used for the central cooling towers, lobbies, and common areas. The landlord controls this. But then you have the tenant space, the actual lettable floor area occupied by companies. The tenants control the taps there. This creates a classic split incentive. I mean, if the landlord pays the overall water bill, the tenant has literally zero financial incentive to conserve. But if the tenant pays, the landlord might really hesitate to invest in expensive water-efficient infrastructure. It's a total catch-22. And simply measuring the water across this divide, it is a massive headache. Landlords face serious real-world roadblocks here. You've got archaic local utility systems that completely lack integration and just do not talk to each other. You've got tenants pushing back, fiercely guarding their privacy and refusing to share proprietary consumption data. To top it all off, lease structures are a highly fragmented mess across different regions. And finally, some landlords fear that constantly demanding this data will just annoy tenants and negatively impact leasing demand. It's a remarkably delicate balancing act for building managers.
Section 5. Strategies for mitigation and fighting back against water scarcity.
Fortunately, the industry isn't just throwing its hands up in defeat. So how are property owners fighting back against water scarcity and mitigating their financial exposure? Well, forward-thinking real estate entities are actively transforming how their buildings operate to protect their assets and their local communities from drought and regulation. To stay compliant and competitive, portfolios are prioritizing very specific short- and long-term water management targets. They're aiming to reduce absolute water withdrawals from local sources and decrease overall daily consumption. They're also working to minimize what's called aquatic impingements, which basically means safely designing intakes so they aren't trapping or harming local aquatic life when pulling in water. And finally, they are striving to dramatically improve the quality of the water or wastewater they discharge back into the environment. And this brilliantly illustrates how those high-level targets become physical reality down in the basement of a skyscraper. Landlords are deploying on-site water recycling systems to reuse gray water. They are implementing closed-loop systems, particularly in huge HVAC and cooling setups, so water isn't just evaporated or flushed away after a single use. And they're completely redesigning building services and amenities to fundamentally require less water to operate in the first place. It's a real game changer.
And remember, these entities aren't just blindly guessing where to deploy these super expensive upgrades. They're using highly sophisticated, data-driven tools. Platforms like the World Wildlife Fund Water Risk Filter and the Global Water Tool allow real estate managers to analyze their entire global footprint, identify their most acute risks, and pinpoint exactly where a water recycling system will deliver the absolute highest financial and environmental return on investment.
Section 6. The ripple effect and beyond the building's walls.
But, as we all know, solving one problem can sometimes inadvertently create another. What are the broader environmental consequences of implementing these aggressive water management strategies? When you start radically altering how a massive building processes resources, the impacts echo far beyond the building's walls. So, the crucial point is that sustainability is rarely a straight line. It's a complex web of life cycle trade-offs. For example, installing heavy, advanced water recycling or closed-loop systems might drastically cut a building's water footprint, but those powerful machines, they require electricity. This can lead to increased energy production needs and, consequently, higher greenhouse gas emissions. Sometimes, aggressive water infrastructure also requires significant changes in local land use. Property owners have to very carefully weigh these trade-offs.
Navigating these complex trade-offs is exactly why standardized, transparent reporting is absolutely vital. Using frameworks like the SASB standards provides the ultimate map for investors. When a company openly discloses not just its water savings, but the energy trade-offs and mitigation strategies it used to get there, it proves they have a truly resilient portfolio, one that's capable of weathering both the climate storm and shifting regulations.
Which leaves us with something to deeply think about the next time you turn on the tap at the office or in your apartment. We've seen exactly how massive population shifts, a rapidly changing climate, and just simple overconsumption are creating incredibly constrained water supplies. These forces are driving up operational costs across the entire built environment, making the invisible financial risks inside our walls very, very real. So ask yourself, are the buildings you live and work in actually prepared for a water-stressed future? Thank you so much for joining this explainer, and keep looking beneath the surface.